So thank you, Doug, for inviting me, and thank you all for coming to listen. As Doug mentioned, Nicole Geneau I've been in the energy sector for about 20 years and started my career in finance, but in the last sort of 10 or so years, really doing project development and finance for utility scale wind and solar projects, so really big ones. And before that, I managed an investment portfolio of emerging energy technologies. So a couple of things that I realized about my career to date and what brings me to Mortensen is I've always been in a role where I act as a translator between the technical engineering folks and the business folks. So really relating the business case of like, why renewable energy? There has to be a business case. Even though it's a really good thing to do, you still need to be able to do it economically. And then second, I've always been in my career at what we call the bleeding edge of technology and innovation. And kind of innovating on new business models, but also new technology. And so I joined Mortensen almost a couple of years ago now. And as I'll talk about a little, the reason I joined Mortensen, it seems like an odd fit because at the time I was pretty convinced that I needed to join an infrastructure fund and help them manage the deployment of their capital to address climate change risks. Like that was 100% the vision. And then out of left field comes this Minnesota-based company that with 65 years of history that just kind of knocked on the door, and the fit was really evident for me. So I like to start by talking about clean energy, and I actually think since I'm talking to the Minnesota Renewable Energy Society, you probably already know most of this. It's what are the drivers today for clean energy? So I think 10 years ago, we'd have a different conversation. We'd have a conversation about policy, about legislation, about targets, about there being a regulatory driver for the reason that companies are buying renewable energy. Today, policy is still a big part of the picture, but increasingly, it's more about the money. The projects themselves have gotten so efficient and the technology has improved so much over 10 years that the projects can stand alone and compete with fossil fuel generated electricity. So we're really seeing the drivers being, in power on the upper right-hand side. Oh, there's a thingy, right? Yeah, oh, I like those. You're seeing the carbon intensity, so the amount of fossil fuel in our general power mix, you're seeing that come down substantially. And most of the other sectors that we track for climate change and commitment to carbon reduction are actually pretty flat or increasing, like transportation. So this is all about how whether you believe in climate change or not, this is all about how we try to get to 2040 and limit the warming of our temperature to 1.5 to 2 degrees. And the transition that needs to take place between the little amount of green here all the way to the big amount of green is pretty huge. So how do we get there? Well, we spend a lot of money, is the bottom line. So global investment in clean energy over the last year was just under $350 billion. And are they not focused?
That's good. Thank you, Mike. Thank you, Mike.
Thank you, Mike. So just over 350 billion in globally. But what does that mean for the U.S.? In the U.S., that was 60 billion last year in clean energy investments. So the trend is still going up. And this market is still very much, I don't expect you to read this slide. In fact, Doug's already heard my joke about this slide. This is only meant as an illustrative example of what I just talked about in terms of clean and green energy projects being competitive with what we call brown power. So power coming from any kind of resource that is fossil fuel based. And so these are the marginal costs. So what it costs for the next megawatt or kilowatt or hour of energy coming from a coal or fossil fuel fired plant. In this case, we're looking at coal or nuclear versus the various renewable energy sources. The powerful message of this slide, and if any of you are interested in finance and economics, I urge you to go to the Lazard Levelized Cost of Energy studies and dig into them. A, those folks are really smart, but B, more importantly, the detail in those reports is astounding, and they're happy to have conversations with people about how they arrived at their assumptions, how they arrived at their conclusions. But the point is, at $14, wind, onshore wind, with the tax credits, which is what subsidized means, is substantially cheaper than the next cheapest, which would be nuclear, in this analysis. And that fundamentally changes the picture from a business investment case. So we're no longer investing in clean energy because it's the right thing to do. We're also investing in it because it makes money, which isn't a bad thing. In Minnesota, we talk about what is the regulatory environment. So it is a vertically integrated market, meaning you can only buy your power from the one company. You don't have any choice as a consumer who you buy your power from. That company has a lot of flexibility in where they buy their power from. So they can generate it themselves, they can buy it from independent power producers, they can do a number of things. But the reason I like this map and this chart is because it really, so Minnesota's up here, and then when you look at what does that color mean? The average two, if you think about a normal distribution, right, the little humpback, you expect most states are going to be in the middle of that, meaning they're about average in terms of the regulatory climate. So how receptive are the governing institutions to change and novelty and pushing the utilities to really adopt new standards, look at things other than brown power production and generation. And Minnesota is about average, which isn't a bad thing. You really don't want to be in the brown, this bottom color. So we have some really interesting opportunities to work with the regulatory institutions in Minnesota. And in fact, they've been quite progressive around the, for example, energy storage discussion and allowing big batteries to compete in the energy market. So they've actually been quite progressive. Again, don't expect anyone to read those numbers. The whole point of these bars, one of the things I get asked about a lot is subsidies. Renewable energy is not going to be competitive unless we subsidize it. Well, so putting aside the whole discussion about a price on carbon, which might levelize the whole playing field, but without a price on carbon, how competitive is it, with a subsidy or without? And the point of this chart is that the upper bars are without a subsidy, and the lower bars are with. And those bars are not very far apart for any of those technologies. And so the whole discussion about renewable energy or clean energy not being competitive unless we subsidize it is just a red herring distraction, a way to kind of divert the conversation. They're very competitive. I mean, look at wind down here. So my background is mostly in wind, so I love wind. But even solar, at $32 versus $36, the differential there isn't very big.
Nicole?
Yes.
So I was trying to figure out what the cost of unsubsidized wind is compared to the cost of unsubsidized nuclear, but it seems like the cost of unsubsidized nuclear is lower, but the buy-in is enormous It's billions, whereas you can build a wind turbine for just millions.
Well, and so I have so not wearing the Mortensen hat. Let's go back here. Yep, okay. So no Mortensen hat.
Yeah.
My personal opinion about nuclear is that we're all subsidizing it, A. So there's no such thing as an unsubsidized cost of nuclear. Second is the way that the accounting and finance works for nuclear, we're not including in our prices for nuclear generated power the cost of waste management. You can't, because it gets discounted back from 300 years from now, which is effectively zero. So just the way the math works, it gets eliminated. But that, to me, is still a substantial thing we should be worried about and thinking about. And you're absolutely right. The capital cost of a new nuclear plant, even a small one, is 200 or 300 megawatts, which for a wind project, to your point, is a really big wind project. And the capital difference is enormous, right? And then you think about the cost of fuel over time. Yeah, they're very different beasts.
I also heard, and I don't know whether you know if this is true, that the nuclear industry doesn't pay for some liability insurance that we covered out.
So my answer is I'm Canadian. And it's different in Canada. And I don't know what the rules are in the US. But in Canada, they are required, so nuclear generators are required to maintain a fund that is supposed to pay for long-term waste management. But that fund is then managed by investment managers who, in the case of one province in Canada, lost a hell of a lot of money in 2008. So can they really fund the liability long-term? I don't know. But this is not an anti-nuclear speech. I'm looking at the camera now. Any other?
I realize that's not your chart, but I'm just wondering, any idea why the wind, that's such a wide variation in cost on wind, even if you take into consideration scale, what you have to do with energy and resource area. Why such, and that's 3.5 times, it looks like, between $14 and $47. Why so wide a spread?
Yeah, it's the wind speed. Fundamentally, it's all about the resource. So in the Midwest, there's a corridor starting in Texas and the Gulf of Mexico, going all the way up the country, the continent, that the wind just screams. And you can get to $14 or $29. But I will tell you that even a small variation in the wind resource has a huge impact on that number. And this is all about the wind. So when you look at places like the Northeast, the wind is actually very good. And so the technology you're deploying to take advantage of the wind in those markets is purposely designed to take advantage of lower wind speeds, but the efficiencies aren't the same. Right? So Mortensen's story, which is also Nicole's story at this point. How many of you are familiar with Mortenson? Yeah. Good. So large general contracting company headquartered here in Minneapolis, actually in Golden Valley. 65 years old, family owned, still family operated. Our chairman is David Mortensen, third generation of the Mortensen family. And he is so committed and passionate about the company and our mission and what we're doing in the market that it's inspiring to hear him talk for me. We, this past year, achieved over $4 billion in revenue, which is a lot. It's a lot of zeros. And that puts us sort of overall in the US in terms of the engineering news record rankings of the largest general contracting firms. We're number 17 in the country. It's not a very inspiring number, but but that's where we are on the list. We have 12 locations in the U.S. So we have offices in Chicago. This is a bit of a test, right? Did I study? Chicago, Denver, Phoenix, Seattle, Portland, D.C., and here, Iowa and Wisconsin. I think that comes to 14. We have about 5,000 team members now. We've been hiring a lot this year. About 2/3 of those team members are going to be our craft labor, so the electricians and our team members who work in the field and build our projects. We predominantly, so here's the answer to the test. Did I miss one? San Antonio. I was just there last week and I missed it. But we're a large commercial contractor. About 70% of our work is in the commercial sector. So the Viking Stadium, the new soccer stadium, the Target Field, the Twins Stadium, I could go on and on. We're quite prolific here in Minneapolis. The new state building in St. Paul. But across the country, we're most well known for our commercial business, but about 30% of our company is in energy and infrastructure. So we're actually number 1 or 2 in utility scale wind and solar construction, so building the big projects. And in 2015, we actually launched a new group called Energy Storage. So we're one of the only contractors that can do, or that does, turnkey battery storage projects, and all those words are important strung together because other folks do pieces of it, but we can do the full scope. So we're builders at heart. This remains true. We love to build things, and we're very passionate about the spaces that we build. But when it comes to our customers and our approach to the business, particularly in the energy sector, it's not just about building. We really want to work with our customers to improve their overall business. So understand what is their ultimate goal. And when in healthcare, for example, their goal is to make people healthier. And so how can we as a construction company facilitate that mission? And that's where, as a company, we've been moving. I don't expect anyone to read the little tiny print, but this is really just to emphasize this concept of having both a commercial group and an energy and infrastructure group. And what I've found, and this was true of myself before I started looking into it, most people are only familiar with one side or the other. So that folks in the energy sector have no idea that we're a commercial construction company and that we do these really big projects. And folks on the commercial side only recently realized, hey, wait a second, you guys have this big energy group. Maybe you could talk to us about our energy needs. And that is, that's really driving how we've developed Mortensen's approach to the energy sector. So way back in the late 70s, we were building hydroelectric plants. In the mid-90s, we started building big wind facilities. In the 2000s, we got into solar. So as the energy industry evolves, Mortensen is always at the front of the pack in terms of how can we be engaged in this evolution. And where we see that going moving forward, and I'll talk about this in just a second, is up here in this right-hand side, 2018, and the reason that I came to Mortensen was to look at distributed energy resources. And what does that mean 1 or 2 degrees away from the meter? So you think about the meter on your house and all the things that are plugged into your service panel, right? At a larger scale, at an industrial facility or at a commercial facility, we could put all kinds of things behind that meter. Solar PV on your roof. We could put little battery storage in your garage. But on the other side, closer to the utility, they're trying to manage all of those resources coming onto their system. So my team is really looking at that intersection between the building, the commercial customer, and the utility. So some energy projects that we've done, like I mentioned the battery storage. So we are one of the first companies involved in the construction of those projects. And we would probably argue that it has been more difficult to execute than we expected. There's lots of challenges with with designing the system and the overall construction. But it remains one of the fastest growing markets, and we remain very excited about it moving forward, and the ability for those battery storage projects to help stabilize the power system and how we get our power. I will save these two guys here. The CTA stands for Chicago Transit Authority, and the Port of Seattle project, and I'll talk about them in just a second. So part of the rationale for how we've been evolving our services and how we're looking at the energy market relates to this slide, which is, previously we did a lot of work here in the big utility scale projects, but we see the world moving towards a decentralized kind of state of being. So we're going to be increasingly houses or industrial facilities will be producing energy at the same time as they're consuming energy, and the sort of back and forth management of that will require us to design and build things differently than we've done in the past. So the trends that we are really that are sparking to us are things like decentralization, digitization. I don't want to say the words blockchain, but blockchain. Electrification. Don't ask me any questions about blockchain. I don't know. I was just at a conference in San Diego on microgrids, which is pretty nerdy to start with. But one of the speakers from the main stage mentioned something about blockchain, and the whole room of 400 engineers went, ugh. And consumer choice, right? You want to be able to choose, can I consume the power from the solar project on my roof? Like, can I put my own solar panels on, or do I have to buy power from the utility? And most people we're finding, have become interested in that conversation. So this is kind of just highlighting the point that I was making earlier about at Mortensen, those commercial worlds and energy worlds are now starting to cross. And we're finding increasingly our commercial customers at early stages in their project opportunities are asking the Mortensen teams, hey, what about energy? What about this microgrid thing that I keep hearing about? What does that mean? And they're then now calling us and saying, hey, can you come talk to my customers about microgrid? Because I don't know what that is. And we're finding that this is a really kind of tipping point for the journey towards using decarbonization in particular. And the example that I will use is sports and entertainment. So these are, in general and increasingly, huge facilities located in urban redevelopment zones. So places where there's a need for economic development in the city, and there's existing infrastructure. So you're going to have to take a whole bunch of stuff out in order to put in this big new building. The building itself has considerable energy requirements, but it's not just the building itself, it's all the adjacent developments. So most new stadiums in the US will have a hotel nearby, or a bunch of sports bars, or the neighborhood will suddenly develop around the stadium. And we've seen this happen even with US Bank Stadium. Some of those condos are just insanely expensive in a neighborhood that 15 years ago, people tell me you may not have wanted to get out of your car. So the redevelopment opportunities are considerable, but the impact to the energy system, so the utility already provides service to that location, right? They're required to provide service to whatever new thing you build there. But that service is really just an extension of what they're already providing. Unless you go and talk to them and say, I really want this new service to be clean, green, renewable. I want to be on a new tariff. I want to include considerable electric vehicle charging infrastructure, meaning the amount of power that I want for my facility is X times greater than what you think it would be. So the average sports stadium might be 20 megawatts. That's energy speak. But when you start to add all of this electrification to the stadium in terms of how people get to the game, what they're doing when they're inside the stadium, the surrounding development, you can increase that by 3 and 4 times, we're finding in the kind of feasibility studies that the consultants have been doing about this kind of redevelopment. So we've been talking to them about how they can turn this whole project into a new eco-district. So how can you share energy? So think about a football stadium. They use it 14 times a year, right? There's only 14. I'm just pulling that number. But whatever the number is of NFL games in a year, it's not high. And then you add on things like concerts or festivals or things like that. It's still not high. Most of the time, that facility is sitting there not used. But the assets you have to build in the facility are still there. So how can you use them on non-game days to support the neighboring community and the neighboring development? And that's the conversation we've been having with the stadium owners around how can you take this asset that you've only been looking at as a sinkhole, basically. You just pay a lot of money for it. It's like the wiring in your walls. You have to pay for it, but nobody sees it, and fans don't appreciate it. How can you change that perspective and become a community benefit?
Nicole, I have a question about that. So how do you leverage opportunity zone census tracts and that type of investor to do stuff like that?
So opportunity zones, it's a great question, are new, relatively new. And we're still figuring out I would say, the mechanics of how opportunity zone investment works in these cases. Okay. So Mortenson does have a real estate development arm, which is exploring some of those opportunities. But no, this is a pure energy, what I'm talking about is pure energy play. So, go ahead.
Well, I'm just talking with this CalSTEP, California Clean Energy Fund, which is an opportunity zone investment fund for opportunity zones, but for clean energy. So yeah. I was wondering if you're looking at that kind of thing.
Looking at it, absolutely. And how you can stack where the money's coming from so that... Yeah, well, and so that each investor is maximizing what they get out of it. So, not familiar with that particular vehicle, but yeah, we would be interested in talking to them. And California is an interesting market. So San Diego is 100% time of use rate. So here in Minnesota, whether you're a retail or commercial or industrial customer, there's a flat rate that changes at certain times of the day, but in general, you're paying that rate. In San Diego, that rate fluctuates constantly. So it's a real-time rate. And if demand is suddenly really high, you're paying a much higher rate. And they've also extended the hours for what they consider on peak. Right? So in theory, peak times of the day would be you go to work, so 9 o'clock in the morning till 5 o'clock at night. And that's kind of what you call peak load, because everyone's using a lot of electricity, and at night you turn everything off and you go to sleep, so you're not using very much. And the kind of border early morning and early evening are shoulders. So it's slightly lower than peak, but not as low as midnight. In San Diego, they've extended what they call peak to go all the way till 9 o'clock at night. What that means is for facilities like stadiums, your games are usually at 7 o'clock at night, you're suddenly going to have huge power costs because you're using electricity during the newly defined peak times. So adjacent development for stadiums will definitely take advantage of the opportunity zone funding structures. But our message to them is, just aside from all of the tax stuff, aside from all of the potential opportunity zone funding, from a straight, it will cost you less money for your energy if you do this. And this being put some on-site solar, some PV generation, include some battery storage to be able to shift where you're getting your electricity from during really high cost times. It will pay for itself in 5-ish years.
Can batteries be in your vehicle?
So a lot of the electric vehicles that have been sold to date do not have the ability to go both ways.
Well, that's my question.
Right.
Sounds like an option.
So new ones do, the Teslas do, but a lot of the original, like the Leaf and some of the earlier models, do not have the ability to, and plug-in electric hybrids do not have the ability to put power back into the grid. They can only take. So that's an absolute opportunity moving forward. In fact, I think a lot about school buses, right? Because for most of the day, they sit there doing nothing. And if you had a fleet of electric school buses on a really hot summer day, you need some additional power at a particular location. Let's drive 4 or 5 school buses over there and plug them in. That's what I think about. So what my group works on is, I affectionately call us the Crazy Projects Division. So new emerging technology, projects that don't necessarily have a home elsewhere in the company. And we've really zeroed in on that intersection of our big commercial customers and our energy customers. And that has led us to electric vehicle charging infrastructure. And I don't mean the Tesla Powerwall in your garage. I mean buses and fleet level charging where it requires significant utility infrastructure to connect it. And the second group, second sort of area of emphasis is microgrids. So what's a microgrid? Does anyone no? Anyone? Yep.
A microgrid is like where you have the solar or the solar panels, and then you have the battery backup, so it kind of like feeds itself.
Yeah.
It's a self-contained grid. And they use them a lot in sub-Saharan Africa where there's no grid,
right.
Off-the-grid stuff where you can just have a microgrid, and there you would hook it to the solar panels, to the battery to store the juice, and then when that runs out, you might hook it to a generator. So it's a complex kind of microgrid. Is that it?
Yes. But the easiest answer is, all a microgrid is, this is the technology hype. Lots of the Silicon Valley folks are going to try to convince you that this is some cool new widget. It's an on-off switch. That's it. It means you can turn the switch off here and not take power from the utility grid anymore. You can take it from wherever you can produce it yourself. So the solar panels, absolutely. If you have your own...
You're required to do that.
Yeah.
You have that switch.
Right.
Because you might have a line man working on the rest of it.
They do, but do you know the utility controls that switch?
Yeah, not my system.
You might be off.
I got a big flag.
You might be off book, Wayne.
Yes.
For the most part, you cannot turn off your own electricity from the grid. You can't, unless you have a microgrid. That's all it is. It's just an on-off switch. It means that you can turn the switch off. You have control of the switch.
The transfer switch in your house. To yours, or?
Yeah, but you wouldn't turn it off unless you're,
Unless they were off or something.
right, unless you had some kind of crazy fire or something in your house. Or I'm trying to think of situations you would turn off your own power. But the point is that with a microgrid, you can turn off the power and still have power in your house or your company or your community. You're not necessarily you don't have to use power from the grid. So for most people, if you turn off the service panel in your house, you're going dark.
Transfer switch.
Yeah. Yeah, if you have a transfer switch, yeah. Most people don't.
Right.
And the utility still has control of that.
So those were transfer switch.
So we're looking at microgrids, and the reason microgrids came about is 2017, December 17th, massive power outage at Atlanta Airport, the busiest airport in the world. They were out of power for 11 hours. Delta alone lost $50 million in lost revenue, in rebooking, and all kinds of things. We're asking infrastructure that we built in the 60s and 70s to be 100% resilient now, to operate all the time with no failure, with no downtime, and they weren't built that way originally. And the utility connection and service usually is not sufficient for them to operate if there's some kind of fault.
Hey, Nicole, back up a little bit.
Yep.
I do have a question about this here with the utility. So how does the Mortensen Integrated Energy Solutions team build these microgrids with the permission of the utility when the utility is all like excited about their integrated resource plans? And doesn't that like have a conflict?
It can, absolutely. It doesn't have to. A lot of utilities now are including distributed energy resources in their integrated resource plans. Some of them are realizing that their customers need higher power quality, and so you're negotiating that interconnection with the utility. And sometimes it's confrontational, but it's way better if you can get them on your side and have a collaborative relationship. And more often in the last 5 years, my experience has been that the utilities are becoming collaborative and wanting to help find a solution. I think that's me. Sorry.
You mentioned the CTA with your charging infrastructure.
Yeah.
Do I infer correctly then that you were not involved with the electric bus charging infrastructure at the Haywood Garage in downtown Minneapolis?
We're not. But in Chicago, they are electrifying, they made a decision, much like Metro Transit here, to electrify their bus fleet. So last year, they decided to buy their first 20 buses, electric buses, and in order to power them, they're installing chargers at both ends of the line, the bus line, and in the middle. And so the chargers they're using, oh, look at that right here. The chargers they're using are called opportunity chargers. And what it means is every time the bus pulls into one of the locations that has a charger, the charger is going to come down out of this little box. This isn't really what it looks like. It looks like a really fancy light pole, actually. And the equipment's going to come down, plug into the bus automatically, and zap it with a high voltage charger each time it pulls in. So it's called opportunity charging because it charges every time it has an opportunity. We're really creative in the energy sector. Yeah, it's 450. For these ones, for this system, it's 450 kW.
Wow.
So,
That's
KW?
yeah.
What voltage?
450 also volt. So the batteries on the bus are 380 volts, but the charging system is 450. So each time these guys come on, suddenly you think about a bus stop, right? There's probably one of those little half glass houses to protect you from the rain when you're waiting to board the bus, and a light fixture. There's not much else. There might be, if it's at the end of the line, a little building with a washroom for the bus driver to take a break and go and use the bathroom. There isn't much else in terms of facilities that would require electric power at that particular location. Not much. Suddenly, we're putting in facilities, the charging infrastructure. In one location, there are 3 chargers. So if 3 buses pull up at the same time and all charge at the same time,
Lights do.
yeah, right? You're suddenly going from 0 or 10 kilowatts to a like 1.5 megawatts. You're spiking like crazy. So to date, they haven't solved this problem in Chicago. They recognize it's a problem, but the project in Metro at Haywood Garage has the exact same problem, what I would call a problem, in that the difference is Haywood Garage has more stuff. They're already using a lot of power at that location, so their service would be higher than at a turnaround in
Put that in
Chicago.
context, those of us that have a level 2 charger for an electric vehicle,
Yeah,
28.
20 kW is your
28.
28? Okay.
Oh, the solution is obvious. One little charger at every bus stop.
No, because although I've been taking this facilitation training, I've been facilitating meetings all my life, and I'm supposed to say yes and, right? Never supposed to say no. That no, you can't do that because the bus still has to deliver people to its location, and if you put a lower power level charger at every location that it stops, it doesn't have enough time at those kind of those layover places to increase the state of charge of the battery. So you need to zap it really hard when it comes in, and the connection with the utility is significant, right? Because all of a sudden you're taking a location that had no power needs and you're putting in huge power requirements. So my personal concern is if we're not thinking about how to help the transit agencies manage their long-term power cost through things like battery storage with shifting the how and where they're getting their electricity from, this message that the industry has been selling that electrification will be cheaper, electric buses in the long term overall will be cheaper, is just not going to be true. And folks will become disillusioned and we'll end up losing the market. So I think that's actually pretty much what we're talking about here. I was going through, so this is what it looks like in the garage. I'm not sure how well these pictures are coming out, but this is the Chicago, so in Chicago, the Navy Pier is one end of the line, right, with all the big touristy stuff. The other end of the line is at the other end of Chicago Avenue to the west, called Austin is the kind of turnaround place. And in the middle is what they call Chicago Garage. And it's just a bus garage. It looks like this. And right now the buses pull in, refuel, and then around the corner over here where you can't see, they line up for cleaning and maintenance and service and all of that kind of stuff. So we're putting in this really pretty structure that will have a charger that'll come down and charge the buses inside the garage.
How long of a period of time?
So they can fully charge in half an hour, from 0 to 380. But the manufacturer and the way that they're going to operate the buses, in general, you don't let the battery get below 80% charge. And once it's unable to go above 80, like over time, as you cycle your battery, with your iPhone or your Samsung phone, every time you plug it in and charge it up, 2 years later, the battery doesn't last as long as it did the first day you got it. So same thing with the bus. We're thinking in about 10 years, they'll need to replace all the batteries in the buses.
I have a question, maybe this is silly, but what if the roof of each bus was solar panels all along the roof and it kind of trickled charged as it was driving around in the daylight? Would that not add very much power to the battery? Okay.
No, and if it was raining or cloudy or, you can't depend on it. But also, it wouldn't have enough.
It wouldn't have enough.
Yeah, the panels currently don't produce enough electricity to make that work.
Do you guys have your own internal engineering, development, and design group, or do you contract out with engineering houses?
Both.
Okay.
So,
This is complicated stuff.
yeah, about 3 years ago, we decided that, and this mainly came out of our energy, our general industry, energy work. We would get engineering plans from our customers, and they wouldn't be great. They'd have a lot of, we'd have a lot of questions. They would go to the field with these issued for construction plans, and the field folks would have tons and tons of questions about the plans. So we launched an internal engineering services group, and really to provide the service for Mortenson. So we're not selling engineering services on the street to other companies. We're doing our own kind of, at the moment, third-party engineering review of plans that we get before we go into the field to build them, to help manage and improve that, the number of questions that come out of issued for construction plans. What it has led to, though, is our ability to do some of this conceptual design on our own internally. Most engineering companies don't like to do projects conceptually at risk, quote unquote. They like to be paid for their time, which granted they should be. We sometimes need to do some at-risk development to determine whether a project is viable or not, and we now just do that ourselves. But yeah, it looks simple, and when it's built, it's going to look like a light pole. It's going to look like the easiest thing in the world, but it's taken months and months and months of design. So this is actually, to the time frame question, if you have limited upgrades, so you don't have to do so much at the location. So Navy Pier, for example, in Chicago, has a lot of power already because there's all kinds of restaurants and things there. So there isn't that much to do there in terms of the electrical upgrades. You could build it you could design and build in about 9 months. But if you have major upgrades required, and lots of cities are facing this issue, it could take 2 years from the time you decide to electrify to the point where you could actually deploy buses at scale. And then I always like to end with this question. So Mortensen believes in innovation, in growing, and in taking advantage of new opportunities. We always wonder, what are we missing, though? What about the market? What about the trends? What about kind of macro development, trends like urbanization and decarbonization and other 7-syllable words? What might we have overlooked in terms of how our company grows and evolves? And I will say about Mortensen, the owners in our senior leadership team really believe in their duty to their employees and to having a culture that takes care of each other like family. And in terms of how we as a company are responsible and committed to building what's next, building the future, and delivering an exceptional customer experience. So it really is about our customers. And I must say, my own targets for whether I'm successful or not do not involve any kind of profit or revenue number. It's all about the customer experience, and are we building a sustainable business within the company that is authentic to where we've come from. That's it.
Take another 5 minutes, 10 minutes for questions if you want.
Absolutely.
I have a question about the batteries. How much variation, when you think about batteries being replaced and big storage facilities and all that, what batteries are you using, and are you always on the lookout for what's coming in that? I mean, is it all lithium?
At the moment, yeah, all the battery sort of utility scale storage projects are lithium ion. the buses are lithium-ion batteries. We do spend a lot of time thinking about what's coming and talking with technology vendors and kind of staying abreast of current developments. In some kind of uninterruptible power supply situations where you need your power to be like super resilient, the data center, they can't have any kind of a bump or blink. Flywheels are actually one of the solutions that work because they respond really fast. So we do look at other technologies depending on the application, but the storage projects we've done to date have been.
What about recycling the batteries?
Yep, at the moment, so in the buses, the bus manufacturer for the Chicago project takes their batteries back, and because they replace them at 80% of their kind of useful charge, they're easily deployed in other stationary storage applications.
That's what I was wondering.
Yeah. Sorry, Mike.
Is it ever tempting? So you drive a bus into the bus garage and there's a sudden huge need for power. Is it ever tempting to put a peaker plant in there and just have it turn on and charge that battery?
As the transit authority, are they going to build their own peaker plant?
I don't know. I'm just curious about, because peaker plants are so much less expensive than batteries, I think.
They're not.
They're not?
The latest, so the Lazard studies will show, and the latest kind of economic analysis, that peaker plants are not, particularly if they're single cycle, they're just built for the sake of turning on power, at the top when you need it.
Yep.
Battery storage is competitive.
Wow, that's great. I had no idea.
Mm-hmm. Oh, Wayne.
Just a quick one. The idea of a switch that takes off everything, from the regular grid, does that also apply to data?
That is a much deeper philosophical question. I don't know. I would say.
With computer hacking.
Yeah, you can't take back what
impossible.
you personally volunteer. So if you have a social media presence, if you have an email, if you participate in the information technology system at all, then you're
hooked up. But you might. But if there was a malicious attack, can you pull?
So cybersecurity is something we.
Maybe you can't talk about it.
Yeah, no, right. I could talk about it, but then I'd have to kill you. That was a joke.
Way back.
Yeah, no. So we do a lot of federal work for the federal government, for the 3-letter agencies, and that's really all I can tell you about that. Is that we do it, but they require very high levels of cybersecurity. So there are architectures and things you can do that would prevent cyber hacking. For the most part, when we talk about microgrids and those control units, right? Because this is what's hackable, is the algorithm in the controller box that tells the stuff what to do. If you, and now the engineer in our team, if he was here, would be like, no, don't talk about that. Because I'm gonna get it wrong. But his point is, if you put the stuff in the box and you can, the slow stuff is hackable. Stuff that's super fast is not hackable. So if you control kind of this, and I'm really messing this up, but if you put the slow stuff behind the fast stuff, it's not so hackable. That's my very generic. Where does this video go? John has been waiting patiently.
Just a quick one down. You said you do about $4 billion worth of business. What portion can you say, what portion of that is in renewables?
So we really only do renewable energy on our energy and infrastructure side, right? So we build the power transmission piece, like the substations and the transmission lines and stuff. But all of our energy and infrastructure work, for predominantly all of it, is in the renewable space.
All 4 billion?
No, so 30% of 4 billion.
Oh, that's it, 30%?
Yeah.
Okay, I missed that.
Because 70% of our work is in the commercial sector.
Nicole, are you guys also working a lot with the bus companies like New Flyer and that to find out what their needs are and how your systems can be compatible with what their needs are?
We're trying, I would say.
Okay.
So transit authorities in general, this is a kind of emerging space for them. Their responsibility, their mission is to get people from point A to point B. And they want to do that the most cost efficient way that they can. They are not in the energy market. And when you start having a conversation with them about power markets, they eyes glaze over. They want to talk about how long is the bus, does it have a cool thing for the bus driver, is there a special heater for the bus driver in Chicago because it's cold every time they open the door. They want to talk about the bus and how the bus gets people from point A to point B. They don't want to talk about the batteries, how long the batteries last, and how they could use energy more efficiently. So yes, we're talking to the bus manufacturers, but they're incredibly protective of their intellectual property because there aren't that many electric buses on the market at the moment. And their customers, so for the most part, they're super happy. This is me going off script again. They really want to sell buses. And the longer that transit authorities go without being concerned about the infrastructure for the buses, kind of the better, because it's all about the bus. The conversation with the transit authorities at the moment is about the bus. Nobody's talking about the infrastructure, the chargers, how they're paying for electricity, the long-term impact on their power bills, how they could incorporate storage or PV solar or other things on the roof of the garage. And that's a conversation the bus manufacturers, in my opinion, have not been all that excited to have. They can have the conversation, and they take different approaches about how they deliver the infrastructure for their buses. So some bus manufacturers like to be more vertically integrated and provide their own branded charger and charging equipment. And some like to partner with other companies. But this is an emerging watch this space. But as a taxpayer, I'm very interested in how my public agencies are using their money and whether they're getting the best deal in the best way possible. And to date, I would say that's not happened.
Is that Chicago project, is that just in the early stages, or is it only conceptual at this point? Or?
Well, we're breaking ground
So you are
next week,
moving
I think. Yeah, it's going, and in fact, they have a new mayor in Chicago who's really excited about electric buses because there's a lot of benefits from an emissions perspective when you think about social equity and the neighborhoods that most buses, the higher density bus service neighborhoods, the lack of emissions. It's a powerful message. But they ordered 20, and that's considered a pilot at this point, and they have 1,800 buses. And the cost of, and this is public information, so I'm not revealing anything too secret, but the total cost of the project is around $30 million for 20 buses and 8 chargers. Wow. Right? So think about time to scale that to 1,800 buses, or at Metro Transit, they ordered 8 buses from New Flyer, and I don't know the cost of that project, but they have 1,000 buses in service, and they presented at council. This is also all public information. They presented at council in December with their plan for their procurement of electric buses. So Metro Transit is going 100% electric by 2023, which is 4 years from now. And the production time frame for the buses themselves is tight. But then when you think about the infrastructure impact to go to 1,000 electric buses, beyond just the amount of power it takes to charge the bus, you also have to completely change the way you operate your fleet if you're going to do like what they call depot charging. So the bus comes back to the depot every night and it charges then. So it goes out all day, it drives around, the battery gets, however low it gets, doesn't really matter, and it comes back to the garage at the end of the day and plugs in and charges. That's the alternative platform to what they call opportunity charging, where it takes a zap whenever it can and doesn't necessarily return to the garage every night to charge back up. But it does, if you want to plug it in every night, you need to be able to plug it in. So just the way you park them in the garage, the way that you service them, the training for your mechanics and your service operators, and it all changes.
Are you also looking at the electric bus up in Duluth, what they're doing up there with their electric buses? Are you watching that?
So they bought Proterra buses.
Right.
Those buses came in January of this year, and peripherally. I'm not sure how their pilot's going. We did build a big bus station in Duluth not that long ago. The Minneapolis operating group did. John?
Since you brought up New Flyer is going to be providing a free bus to MRES, basically.
Oh, great.
In August, in association with the American Solar Energy Society meeting, we're going to have an electric bus tour of solar facilities owned by the city of Minneapolis, and an electric bus tour of solar-powered brew pubs in Minneapolis.
Okay, which is a growing trend in Minneapolis. Absolutely. I think that's fantastic. And New Flyer they have a big manufacturing plant in St. Cloud. And the first 8 buses that Metro Transit is procuring are New Flyer buses. So, yeah.
Yeah, I went through the plant up there. It's amazing. 700 people and just a great facility. Anyway, let's go ahead.
Thank you.